Welcome everyone to the ADLINK podcast, your gateway to the world of edge computing and beyond. My name is Patrick Chiu, the Senior Product Sales Manager of Edge Computing Platform. The topic of today is it's an exciting one, which is the revolution of AI manufacturing, the shift from FPGA to GPUs. Just to give a brief overview, in today's technology landscape, some of the industrial sector are actually going a transformation with the adoption of using GPU over FPGAs. The shift is primarily driven by the increasing demands for higher performance in parallel computing, which are essential for processing large-scale data and executing complex algorithms. With the robust parallel processing capabilities of the GPU, it offers substantial advantages in terms of programming accessibility, scalability, cost-effectiveness, and energy efficiency compared to FPGAs. Today, we are pleased to have the subject expert, Mr. Irfan Ali from NVIDIA, joining us to dive into this topic in more detail. To share a brief background of Irfan, Irfan is a global leader for NVIDIA's Edge segment business. With 3 decades of experience in Schlumberger, Cisco, and now NVIDIA, Irfan has been a driving force for accelerated computing, AI, and edge technology. Irfan, it is fantastic to have you today, and we look forward to learn more valuable insight from you.
Patrick, great to be here.
All right, wonderful. Okay, so just to kick things off, Irfan, so in your point of view, understand that NVIDIA is a leading partner in this adoption. So what is driving this FPGA to GPU adoption?
Well, I think, Patrick, to understand that, the trend is that we are seeing more and more accelerated computing in different workloads that we at the edge, and that's primarily driven by the need to put AI in different aspects of the process cycle in the different industries that we're in. And one of them has been where traditionally you leverage FPGAs to do that workload. So we're seeing that in these environments, sometimes it's more advantageous to transition to a GPU infrastructure to be able to get to a more standardized platform to be able to do this transition.
Understood. So for this adoption, what kind of impact do you see for this FPGA to GPU in terms of the development cycle of the various projects? Can you give us some example here?
Yeah. I think if you look at the typical, I guess, workflow that we have seen is that you typically have some kind of high definition sensor of some kind, whether it's a radar or a 5G or even a high definition camera, like we use in the medical industry, for example, right? So you have the high definition camera connected to an FPGA interface that then connects via proprietary protocols or cables to a camera control unit that is also built on FPGA that does the signal processing and then sends that signal to a capture card in a compute node where you may have a CPU and a GPU for processing, right? And I think what we've seen is that in that development cycle, that typically takes 24 to 36 months, you may be able to transition some of that workflow over to a GPU-based system. And what I mean by that is to take the high definition sensor, the camera in this case, that I was using as an example before, to have a lightweight FPGA interface that then transitions that raw data over to let's say a GPU-based system for processing versus an FPGA-based system. That's sort of the transition that we've seen.
Wonderful. So Irfan, besides the hardware development cycles, do you actually foresee any potential challenges from transitioning to GPU in terms of the software and process developments?
Well, I would say that the challenge would be the transition of the workflow over from FPGA based to GPU based. Obviously, the workflow is the same, but the way you address it is different. So there's going to be an early investment in that transition. But once that transition happens, I think you're able to see that for each iteration of changes, like let's say your sensor changes, your high definition camera, you go from one model to the next model because it offers you higher resolution or whatever the reason is for that change. That typically in a typical FPGA environment sends a cascading of upgrades that needs to happen, right? The FPGA control boards, the camera control unit, the capture card, all have to be changed, and that in that proprietary mechanism way, and the signaling has to be changed. So I think that the transition to the difference would be if you were to do it on a GPU-based system, because the systems are typically off-the-shelf standard-based system as far as getting the input. That would be a lot easier, where you don't have to the whole chain does not have to change because of the FPGA interface change with the sensor, right? It only the part that is connected to the sensor, the light FPGA that's making the slight conversion needs to change, but everything else can stay within the GPU-based system. It's a little bit hard. I'm describing it. Hopefully, you can visualize this, because I know it's easier to see. A picture is much easier to describe than describing in words. But effectively, you're alleviating one step in the processing of it via GPU, because you need to process the signal and then send it to a capture card in the FPGA environment, where in the GPU environment you process the signal and do the compute of that signal right on the same node, because the GPU is doing both jobs effectively.
Understood. Yeah, that does sounds very fascinating. So Irfan, so could you also give us some use cases that would benefit from this adoption?
Yeah, I mentioned a couple earlier, but I think we're seeing in the, let's say, in the semiconductor environment, where you have wafer inspection. Typically, those are really high resolution, very detailed cameras. That signal processing is one that we're working with some customers about with this types of approach. In the medical industry, where you have medical devices that are taking like an endoscopy system or a robotic assisted surgery type system, where they have these FPGA-based control units. A lot of those we see that can be transitioned over to a GPU-based system, and we have in discussions with customers in doing that already.
Understood. So it sounds like some of these applications will require like high definition cameras that to do video capturing and processing. So how will those signals be processed if we want to use a GPU?
Yeah, that's a good question, because I don't think I clarified that earlier. So yeah, in some cases they're high definition cameras, in most cases, but we also have, like I said, radar where they're looking at radio signal to bring that in high definition in high volumes, or even 5G signaling. But all that signaling can be converted. We have a process called hollow bridge. And what hollow bridge does is it actually has a lightweight FPGA that converts the raw signal coming in from the data from the camera or from the sensor, and then converts that over to Ethernet. And now that you have a very standard protocol for development, right, or for transport, that Ethernet can be then ingested into a system an accelerated system that has a GPU in it to do processing. And in many cases, based on how you connect that Ethernet signal, especially using our ConnectX-7 type technology, we can do a GPU direct. So that way it bypasses, it goes right into the GPU, reducing the latency requirements, and that signal can be processed right in the GPU. Right. So yeah, we would, in the way we approach it is, like I said, in a very standard way. So we would convert that camera signal or the sensor signal over to Ethernet, and then transport that into the processing unit, versus different proprietary protocols that you may need in other environments.
Understood. So in terms of the protocol or the sensor development, which ties very heavily into this. So what kind of, in the grand market of a scheme, right? So what do you see in terms of that infrastructure adoption? Do you see a lot of partners that's been developing this type of a solution to support this adoption?
Well, we see different customers in the instrumentation space, in the medical device space, who are looking to make this transition. So we are talking to several of them in doing that because what it does is for them it reduces their development cycle from 24 to 36 months down to 12 to 24 months. And so not only does it shorten the cycles, obviously once they get over the hump in transitioning their workflows over to GPU-based systems, but then in the future generations of the product, it becomes easier from a development standpoint because then it becomes more software defined. Then the system's infrastructure system may stay the same. If you change the camera, you just change the FPGA interface of the camera, but the processing platform stays the same, and you really then adjusting the software on top of it. So it really becomes a software defined endeavor, and that's what's making it attractive to these customers. So like I said, we're partnering with the medical device manufacturers, we're partnering with industrial signal instrument manufacturers and signal processing type customers and partners that are looking to adopt going into this type of architecture, so that they can make it easier for their customers, and at the end of the day, we want to get to market faster and reduce their cost, right, for their product and processes. So that's what this allows them to do.
Wonderful. So Irfan, so in terms of the adoption timeline, based on your point of view, are we very early into this, or what kind of time horizon do you foresee for this adoption?
Yeah, we definitely are in the beginning stages of this, right? So we have customers that are showing tremendous interest in transitioning to this, and we certainly will have these early adopters. As I mentioned, the development cycles are 12 to 24 months. So just even the early adopters, you won't see them come up with with this new workflow or new products based on these systems for another 1 to 2 years. But then you'll have, what we're seeing is there's a healthy pipeline of people looking at making this transition, and you probably have either fast followers or people that are starting their journey a little bit later. So I would say that the time horizon for this, for us, the way we're looking at it is 1 to 2 years for the early adopters, and maybe 2 to 3 years and beyond for the rest of the folks that are looking into this. Now, some industries move faster than others. I know the medical device industry seems to be moving very fast, versus the industrial inspection and semiconductor inspection will take longer. They're a little bit longer to do that, so they may be in the 3 to 4 years, where medical would be 1 to 2 years.
Understood. Thank you very much, Irfan. It looks like we are about time here. So just to wrap up, I just want to say thank you, Irfan, for joining us today. We have definitely learned a lot from you, and this has been a very valuable session. As for audiences, please stay tuned for more upcoming engaging discussions, and we will talk more about the future of technologies. Thank you again, Irfan, and we will keep in touch.
Thank you so much, Patrick.